In the previous video, we looked at calculating concentration of solutions in grams per decimeter cubed. The unit was number of grams in a decimeter cubed of water. Now, in the same way there's different units for length, like meters or inches or feet or miles, there's different units for concentration. Chemists often use another unit of concentration called the number of moles in a decimeter cubed. So if you haven't yet done the grams per decimeter cube calculations, I'd suggest you do that on the previous page of this booklet before you do the moles per decimeter cubed calculations. But if you can do the grams ones, these should be quite straightforward, hopefully. The only difference really is we have to remember how to work out moles, and to do that we need our equation that we come across so often in chemistry. Moles equals mass divided by the relative atomic mass if it's the mass of an element, or the relative formula mass if it's the mass of a particle with ionic or covalent bonds present. I'll put the abbreviation down for formula mass, and MR is the one I use. So that's our equation. We have to learn this. There's just no two ways about it. If you don't know that, you have to learn it. It helps enormously. We don't need to for this particular calculation. It helps enormously if we put it into a formula triangle as well, because we have to be able to rearrange it for other calculations. That's why that's there. There's a divide there, mass is on top of the divide. There's a divide there, so that's right, mass on top of the divide. And then the other two spots have to have moles and formula mass beneath, but that's not important for this today. So a few questions here just to remember how to calculate moles, because if we're going to calculate the number of moles in a decimeter cubed, we have to be able to take a mass and convert it into a moles. So these questions all have a mass. We know it's a mass because it's got the unit grams at the end of it. Okay, grams or kilograms or tons are units of mass we often see in chemistry questions. So we've got 2.54 grams of copper here. So moles equals mass divided by atomic mass. Because this is the mass of an atom, also mass of an element. So mass is 2.54. 2.54 divided by the atomic mass is given in the question there. Relative atomic mass 63.5. Oops, I put a decimal point in the wrong place. 63.5, not 6.35. 63.5. So let's stick that into a calculator and see what we come up with. So we've got 2.54 divided by 63.5 equals 1/25 or 0.04. So that is 0.04 of a mole, 0.04 of a mole. I'll do one more of these. These are hopefully quite straightforward. 156 grams of magnesium, how many moles? So moles equals mass divided by atomic mass, and always get in the habit of writing out the formula. The more you write out in these questions, you just drill yourself into doing it properly, and it also just gets stuck in your head, so you'll never forget it. Mass is 156 grams. We know it's a mass because it's got a unit grams at the end of it. Mass 156 divided by atomic mass. Here it is, relative atomic mass of magnesium 24. 156 divided by 24, let's stick that in a calculator and see what we end up with. 156 divided by 24 equals, can we see that? That's going to be 6.5. Equals 6.5 moles. Okay, moles. You can do number 3 on your own there. Right, so now it gets interesting. Can we calculate concentration of solutions in moles per decimeter cubed? So we've got 80 grams in this example of sodium hydroxide, and it's dissolved in 1 decimeter cubed of water. What's the concentration of solution in moles per decimeter cubed? Okay, first thing we need to do is calculate moles, just as we did in these questions here. Okay, so we've got the formula moles equals mass over MR, formula mass, the relative formula mass. Well, this formula is Na1, O1 and H1. So we've got all the atomic masses down here. The relative atomic mass of oxygen is 16, sodium's 23 and hydrogen's 1. So we've done that there, 23 and 16 and 1. So that's all going to add up to 40. We've got 80 grams of sodium hydroxide, so the mass is 80 divided by 40, that's why we've got 2. Okay, it's 2 moles. Now, this 2 moles happen to be dissolved in 1 decimeter cubed of water, so that becomes straight away the number of moles in a decimeter cubed. Okay, if we didn't have 1 decimeter cubed of water, we'd have to do another step. Let's have a look at some of the next questions. Right. So let's do this first one here. We've got 53 grams of sodium carbonate dissolved in 1 decimeter cubed of water. So again, we've got a very helpful 1 decimeter cubed there. So let's work out the number of moles straight away. because we need to do that. So moles equals mass divided by formula mass. So we need the formula mass to start with. It's Na2CO3. Okay, so Na2, that's going to be 23, but 2 of them. So 23 plus 23. It's carbon. There's no number after the carbon, so there's a 1. Carbon's got an atomic mass of 12 plus 12. And oxygen 3. Oxygen is 16, so it's going to be plus 16 plus 16 plus 16 equals. Okay, quickly stick that in a calculator. So it was 23 plus 23 plus 12 plus 16 plus 16 plus 16 equals 106. The formula mass is 106. Okay. Moles equals mass divided by formula mass. So the mass now, the mass here is in the question. It's the mass because it's got the grams at the end of it. So 53 divided by 106. Well, I don't need a calculator to tell me that's a half. Okay. So let's just quickly stick it in there to do it, to prove it. 53 divided by 106 equals a half. Okay, 0.5 of a mole. So that's 0.5 of a mole. Now that half a mole of sodium carbonate is dissolved in 1 decimeter cubed of water, so that straight away becomes 0.5 moles in a decimeter cubed per decimeter cubed. We put the minus there, that tells us it's per moles per decimeter cubed. That's the concentration. So that's quite an easy one because it's got 1 decimeter cubed of water. This one's also got 1 decimeter cubed of water. Let's not do that. This one's got 1 decimeter cubed of water. Number 4, let's have a quick look at this one, because this is slightly harder. This time we've got sodium hydroxide solution made by dissolving 100 grams of sodium hydroxide and making it up to half a decimeter cubed. Okay, so this time we're going to need to work out the formula mass of sodium hydroxide. Sodium hydroxide has the formula there, NaOH. So, moles equals mass divided by relative formula mass, Mr. So the Mr of sodium hydroxide, there is 1 Na, 1 oxygen and 1 hydrogen. 23 is the Na, so 23 plus oxygen is 16, plus 16, plus the hydrogen is 1. Add all that up, it's 40. So mass divided by Mr. Mass is 100 grams. 100 grams divided by the 40. 100 divided by 40 is 2.5. I'm not going to put that in a calculator, you can just believe me. Okay, 2.5 moles. So it's moles per is divide, decimeter cubed. So we now have to take the number of moles, 2.5 moles, 2.5, dividing it by the number of decimeter cubed of water, 0.5. Okay, so 2.5 divided by 0.5 equals 5. So the concentration of this solution is 5 moles per decimeter cubed. I've written it like that. Let's write it the other way. 5 mole per decimeter cubed. Let's write it like that. That's a better way of writing it. I'll cross that one out. Okay, 5 mole per decimeter cubed. They mean the same thing, but that's just how you will see it written in questions. Mole, dm, -3, moles per decimeter cubed.